Hello, my name is T. Kaushik Reddy from Computer Science Engineering, Section B, and my topic for TOC, that is Theory of Computations, is Building Blocks of Software Design. So let's get started. First, software design. Next, software design, how the software is designed for the topic. So the software design is an iterative process through which requirements are translated in blueprint for constructing the software. Initially, the blueprint depicts a holistic view of the software. So the software, software design. So this the software design for the building blocks of software. So first, the process of design engineering. So during the design process, the software specifications are transformed into design models. Models describe the details of the data structure, system, architecture, interface, and components. Each design product is reviewed for quality before moving to the next phase of the software development. At the end of the design process, a design model and specification document is produced. This document is composed of design models that describe the data, architecture, interface, and the components. So this is the design. First, the interface, the procedural design, next the interface design, and the architecture and the data design. So first, the data object description, entity relationship diagram, data flow diagram, process specification, data dictionary, state transition diagram, control specification. So design specification models, data design, created by transforming the analysis information model, data dictionary, and ERD into data structures required to conjunction with the design of software architecture. More detailed data design occurs as each software component is designed. Architectural design designs the relationship among the major structural element of the software. The design patterns that can be used to achieve the requirements that have been defined for the system, and the constraints that affect the way in which the architecture patterns can be applied. It is derived from the system specification. The analysis model and the subsystem interactions define an analysis model DFD. Next, design specification models, interface design, procedural component level design. So first, let's learn about the interface design. So it describes how the software element communicate with each other, with other systems, and with human users. The data flow and the control flow diagrams provide much of the necessary information required. Next, procedural or component level design, created by transferring the structural elements defined by the software architecture into procedural descriptions of the software components using information obtained from the process specification, control specification, and the state transition diagram STD. First, the fundamental concepts. So design fundamental concepts, abstraction, architecture, patterns, modularity, information hiding, functional independence, next refinement, next refactoring. So these are the basic or the design for the fundamental concepts for the design that are abstraction, architecture, patterns, modularity, information hiding, function independence, and refinement and refactoring. So the architecture design, the overall structure of the software and the ways in which the structure provides conceptual integrity for system. Design can be represented as structure model, framework model, dynamic and process model, and functional model. So first, the structure model defines the components of system examples, modules, objects, filters, and how the components are packaged and interact with one another. Next, framework model, increased level of abstraction. Next, dynamic model and process model. Next, predict behavioral and reliability aspects. Functional model depicts functional hierarchy. Patterns A pattern is a common solution to a common problem in a given context. While architecture style can be viewed as patterns describing the high-level organization of software, their macro architecture. Other design patterns can be used to describe details at a lower, more local level, their micro architecture. Creational patterns, example, builder, factory, and prototype and singleton. Next, structural patterns, example, adapter, bridge, composite, decorator, facade, flyweight, and proxy. Next, behavior patterns, example, command, interpreter, iterator, mediator, memento. Next, observer, strategy, state, template, and visitor, etc. Next, design pattern. Design pattern enables a designer to determine whether the pattern is applicable to, there are 3 points. First, the designable pattern enables a designer to determine whether the pattern works on the following 3 points. The first point is applicable to current work, can be reused, can serve as guide for developing a similar but functionally or structural different pattern. So first is applicable, is the pattern is applicable for the current work or not. Next, it can be reused or not. And next one is the can serve as a guide for the developing a similar but functional or structural different pattern. Next, modular design. Easier to change, easier to build, and easier to maintain. So information hiding. Principle of information hiding says that a good split of modules is when modules communicate with one another with only the information necessary to achieve the software design function. Next, so information hiding enforces access constraints to both, like that are procedural detail with the module and local data structure used by that module. Data hiding is a criteria for modular design. How to know what modules to create. Next, information hiding. Module control interface, algorithm, data structure, details of external interface, resource allocation policy, secret, a specific design decision, clients. Information hiding. The benefits for the information hiding are reduces the likelihood of side effects, limits the global impact of local design decisions, emphasizes communication through controlled interface, discourage the use of global data, leads to encapsulation and attribute of high quality design, results in higher quality software, and these are the benefits for the information hiding, mainly that are reduces the likelihood of side effects, limits the global impact of local design decisions, discourages the use of global data, emphasizes the communication through controlled interface, results in higher quality software, and lead to encapsulation and attribute of high quality design. A range of cohesion. So there are the range of the cohesion varies from low to high. From low, it's coincidental. Next, the logical. Next, the temporal, procedural, communicational, sequential, and functional. Or you can say that it may vary. It may vary from high cohesion to low, that are functional, same, sequential, communicational, procedural, temporal, logical, and coincidental. Next, range of coupling. So it may also coupling also vary from high to low or low to high or loose. So high coupling, content, common, external, control, stamp, data, and uncoupled. At the lower level, it means that it is uncoupled, nothing else. So content coupling, worst, when a module uses or alters data in another module, it's the worst thing. Next, a common coupling, two modules communicating via global data. External coupling, modules are tied to an environmental external to the software. Control coupling, two modules communicating with a control flag. Stamp coupling, communicating via a data structure passed as a parameter. The data structure holds more information than the recipient needs. Data coupling, best, communicating via parameter, passing the parameters. Passed are only three, those the recipients needs. No data coupling, independent modules. Next, the summary. So these are the summary, nothing but the difference between the cohesion and the coupling. So the first difference between the cohesion and the coupling is, the first thing is the measure of the strength of the association of elements within a module. Here in the cohesion, the measure of the strength of the association with an element is within the module. It's not above or the around, it's within the module. Okay. Then the first then in coupling, the measure of the dependence of one module to another. So here the in cohesion it is within the module, whereas in coupling the measure of interdependence of one module to another. Next, second point, it is a degree to which the responsibility of a single component form a meaningful unit. So here the how the meaningful unit is formed is like it is a degree to which the responsibility of the single component form a single meaningful unit in cohesion, whereas in coupling it describes the relationship between software components. And the last point, the last difference between both cohesion and coupling is it is a property or characteristics of an individual module. So here the last point it says that in cohesion it is a property or characteristics of an individual module, whereas in coupling it is a property of collection of modules. So in cohesion, and the first point says that in cohesion the measure of the strength of the association is within the module, and in coupling the measure of independence of an module to another. Next, it is the degree to which the responsibility of a single component form a meaningful unit. And here it describes the relationship between the software components. In coupling, it describes the relationship between the software components. And the last difference is in the cohesion, it is a property or an characteristics of an individual module. It is a property of collection of modules. And you can see the stamp coupling communicate via a data structure passed as a parameter. The data structure holds more information than the recipient needs. Data coupling, best communicating via parameter passing. The parameters passed are only those that the recipient needs. No data coupling, independent modules. So this the already summarized them, the difference between the cohesion and the coupling. So this is, so yeah, thank you. This is the AAT Tech Talk for my subject, the TOC, Theory of Computations. The topic name is Building Blocks of Software Design. So at last, the summary tells the main differences between the cohesion and the coupling. That the measure of the strength within the module, here the independence of one module. It is a coupling is a combination of software components, and it is not, and it is a property of characteristics of an individual module, whereas the coupling, it is a property of collection of modules. It is cohesion is the property of single module, and the coupling is the property of a collection of modules. So yeah, so this is a topic for my subject TOC, the theory of computations. My topic name is building blocks of software design. Yeah, thank you.